Bev? He left. All right, anyways, then carry on.
How do you get the southern star rotation in the sky?
That's a good question.
Like, dude, you've heard that before. Come on, man. And suppose the sky doesn't have anything to do with the ground. Like, everything about your globe is reverse engineered from the sky. It doesn't have anything to do with actually measuring the Earth. So there's that, you know. Take away the sky and you take away your globe.
Yeah, and Glenn, how much of that Alan's Kool-Aid if you're drunk?
No, I mean, that's the thing. I'm not even sure if Bev is aware that longitude is in the sky. I think he thinks it's on the ground. I don't know. We got to get our questions ready for the Bevster.
It's always the sky interpreted and translated to the ground. It's all it ever is. They wanted Antarctica to kill us, but the truth is that it didn't give them anything new, even.
SE here? SE, can you send that or put that video in the chat? If you're here, I wanted to look at it. Empty promises from Bev. You never put it up that I saw. This shorter than a straight line video.
There were people arguing earlier too about the horizon not being, the optical convergence point of, the limit of your vision. You can say that 100 different ways. You can call it the angular resolution limit. You can call it your azimuthal grid of vision or whatever. It's a perspective. It's all the same idea that, you have an angular resolution limit to your eye, and that is 0.02 degrees. That in the globe, yeah, they tell you that it's physical looking over the curve, and that's what it is. But that's not what the horizon is. The horizon is an optical place that's, way beyond what they tell you the curve would be blocking. But it's refraction that brings it up over. But you see, the refraction is always perfect, and it doesn't matter what the atmospheric conditions are. It could be cold as hell outside with a ton of moisture in the air, and it just looks flat. Or it could be hot in the desert, and it just looks flat. It doesn't matter what it's just standard refraction. You just plug in what you need, and away you go.
Yeah, England, were you there when Taylor presented a finding from a 1913 surveyor project from India? Where
she did come in here and present it?
Yeah, it was just 2 days ago, where I believe they took measurements during the day and then the evening, and then from their findings, if I'm not mistaken, please correct me if I'm wrong, people, the measurements taken in the evening showed a flat Earth or no dip, if I'm not mistaken. I'll have to get her to confirm. Maybe someone was there when she was presenting it that's in the audience.
No, that sounds about right. Yeah. I was hoping that. Yeah, I must have. I mean, she mentioned it. I heard her mention it, but I didn't hear her actual presentation on it. And I'm deaf. That was yeah. Good on you bringing that up. Exactly. It's right in the wheelhouse of what we're talking about here. Where I was trying to remember exactly what else she said too. Some dude actually went and did the freaking legwork of figuring out what it would take to understand refraction in the sky with the different atmospheric pressures, temperatures, and humidity levels. And it's like,
you're not saying anything though. You're just wasting our time. You're not.
No, we're talking exactly about refraction. You want to what? We're talking about refraction, bro, and how you guys.
What about refraction? First of all, do you acknowledge refraction? Is refraction a real thing to you, like in your model?
Well, we were just talking about exactly how it should be calculated for, and how it took one of us to actually go dig up the fucking data.
Question.
What was it now?
Do you acknowledge refraction or not?
You're hilarious, bro. Of course, refraction exists. Okay. Does it exist to the degree that you can turn a little slider up and see your ass from the other side of the world? No.
Clearly, yes. That's what the sun's doing in your model. So, yes. Actually, that very thing. Turn your ass back around and see it. That's exactly what it's doing.
Yeah, it's not. It's refraction happens, but not to the degree you think it does.
It's doing it to the 180th degree in your model. The sun's over there. You turn back, ass backwards around, and see it over there. Isn't that what's happening? Yes, it is. Thank you.
I mean, yeah, that wasn't really what I was talking about, but all right.
Yeah, so for example, Whitsitt was in the southern hemisphere and he saw the sun to the south of him. How did that happen if the sun was north of him?
I mean, you've seen the kinematic equivalence equations, and we've said it 100 times that what happens in the sky doesn't determine the shape of the ground.
So in other words,
Like,
the sun
I'm
is
really
north, but
being
you see it in the
honest with
south?
you. When I'm being objective about the ground being fucking flat and the sky does look like a sphere, I'll give you that the sky looks like a sphere. It's the optics of the sky are remarkable. They're remarkable, and I can't explain all of them. I'm telling you right now, they all take place over a flat ground, though. This is
The
the
thing
way
is,
it is.
we Globers can explain everything that happens in the sky to a high degree with really good accuracy and prediction. So that's
No, you
probably.
can't.
Oh, really?
Yeah, there's just a couple things right off the top is perihelion shift. There's multiple things within that paradigm that relativity does not have an explanation for.
Yeah, there's a shift in the orbits.
Yeah, so that is not a dynamic explanation. And if you want to go into all the way down the road that Professor Parks and Dr. Bennett went down, then we can go down to that road and get down to the end of it where they disagreed over the definition of the word dynamics, which blew my mind. And then Professor Parks said, yeah, just because a model doesn't make correct predictions doesn't mean it's not dynamic. And that just, no. Dynamics is very specifically making a correct prediction. So that's the end of that road. If you want to make a different argument, I'd love to hear it.
Sure. The sun sets. That's a good argument.
What was that?
The sun sets. There's a time
Yeah,
in the evening
that's another
when the
problem
sun sets
too.
and you can't see it anymore.
Yeah, it's really interesting. I like how you're simplifying this too, because I think people do try to overcomplicate this.
Yeah, I agree.
The sun sets because of perspective.
No.
Now, my argument for this is I would love to hear your scientific reason for suggesting that the sky is the only place where perspective doesn't apply.
A perspective applies in the sky. That's why we don't see the sun.
No,
change
not it,
size.
very specifically in the heliocentric model, it does not apply to the sky. So
It
you
does.
better rethink what you're talking about, bud.
No, it does.
No, it very specifically does not, and I've had Ruhif come in here and fucking correct Globers on it. You see, this is the double speak crap, where if people don't know what you're talking about, it's going to confuse the shit out of them. In the heliocentric model, it does not apply to the sky, dude. Perspective can apply to the sky in the heliocentric model. Your angle to the star is your fucking position on a globe in the heliocentric model. You didn't know
Right.
that? See, this is why I get kind of pissed off about it a little bit, is because you talk like you know what you're talking about,
I do.
but you
I do
don't.
know what I'm talking about.
So why do you disagree with other Globers?
I'd have to talk to them and find out what we disagree about. So
Yeah, see, I know your model better than you do, and that kind of
Oh, you do?
sucks, and that's why you should go do your homework.
okay, so why do we say that the sun doesn't change size as it sets in our model?
It does actually, if you go look at it.
That wasn't
People
my question.
Hold up
I said-
videos.
I said we say it doesn't change size in our model. Why do we say that?
You're strawmanning the globe, though.
No,
By saying
I'm
that,
asking. He
because
said
it
he
does.
knew. He said he knew my model better than I did. So I was asking him a simple question. See if he does really know it better.
Like a loaded question, I find. It's like, when
No,
did you
it's
stop
a- it's
beating
a
your
test.
wife?
Why do you guys say that the sun doesn't change its
Right.
angular size when it moves across the sky?
Yeah, that's the question.
Because you have to.
They don't
because
say
it's
that.
No, I'm
93
asking-
million
I'm
miles
asking-
away.
What's our explanation?
They don't
Because
even
it's
say that. You guys
93
claim
million
it does
miles away.
change. You guys claim it does change size throughout the course of a day.
We do? I don't know.
Yeah, it has to.
Why?
Because you're getting farther. You're rotating backwards away from the sun. You're getting farther away from the sun. There's an angular size change.
From
It's
93 million
7/10.
miles to 93 million and 2,000 miles?
Yeah, it's 7/10 of an arc second. You didn't know that?
7/10 of an
I know
arc?
your own
don't
model
understand
better than you, Matthew. And that's no bullshit.
That's dope. Oh man. No, yeah, that perspective in the sky thing just gets me going. I guess it triggers me, as they might say, because it is a cut and dried thing where we're looking at the same exact thing, but there's a very different way to interpret it based on whether you believe it's a globe or you believe it's flat. And one of those interpretations is correct, and the other one isn't. Like I said, yeah, it is kind of simple if you know what you're thinking about. So, like, in our model, the sun is setting because just like the street lights, you're looking down a road with street lights. They look to converge at a distance with the ground. It's the same reason that the sun sets.
Yep, and the
In our
streetlights
model,
get
and
smaller
that's
and
the same-
smaller.
Matthew, if you
Yeah,
do end
yep.
up talking to Bev, tell him about how you think level's perpendicular from a vertical.
Yeah. Yep.
Yeah, I think you should lead with that when you talk to him.
I think we'd probably agree with it, but I don't know. So 7/10 of an arc second, that doesn't match. I mean, that would be a change in distance of 18,000 miles. So I don't know where you get that, because during the course of a day, the distance would change. Well, maybe it's on that order.
Yeah.
Okay, so 7/10 of an arc second is pretty small.
Okay, but changing nonetheless.
I wonder if it's within the amount that
Larry
we
has a
measure.
tool from the 60s that can measure a third of an arc second. So
Oh, okay.
it's state of the art though, but it's
except
from the 60s.
except he just said he had videos, and I don't think a video is going to show 7/10 of an arc second.
A video of him using the tool might. So I'll concede that it might change that much.
I mean, it's what the globe demands it changes that much.
Yeah, but that's per day, not from noon to sunset.
It changes twice a day, right? From sunrise to when it's above you, and then from when it's above you to set.
No, it doesn't.
No.
No, in all the ephemerides I pull, I get the diameter of the sun for the day, and from day to day, it'll be a fraction of a second different, not from noon to sunset.
Oh no, it's supposed to change throughout the course of a day in the heliocentric model. We just went through that with Matthew.
Yeah, good enough. Yeah, okay. Then I'll just keep doing what I'm doing and get the right answers, because it only changes by 1 arc minute over 6 months.
Okay, and every day it changes throughout the course of a day.
No, it doesn't change.
7/10 of an arc second. Yeah, the geometry of the globe demands that it does.
Well,
Yeah, but
then
Jeremy, that's only
yeah, because the
100th
rotation of the Earth, rotation of the Earth combined with the orbit of the Earth. Yeah, I think you're going to be hard pressed to justify that.
The geometry demands that it changes that much.
Well, okay, we'll present the paper. I maybe I stand corrected. Okay, I only use the nearest arc second and in my work, so you're right. A portion of an arc second might escape me, but as I go from day to day, or when I query the tables from noon to late afternoon, I'm getting I'm not finding any change.
Can't you measure 3/10 of an arc second?
No, not to the sun.
Yeah, that's like
the sun is moving. Yeah, the sun is moving. I said the finest grade instrument has a direct reading of a quarter arc second. Yes, but that in practice, to astronomy with that instrument, yeah, fractions of an arc second, it's tough. You'd have to spend days making repeat measurements.
All right, we'll do it up.
But the question still remains: why does the sun appear about the same size as it sets within?
Well, yeah, because if it's only 4,000 miles away, yeah, it's got to change a fuckload more.
Unless there's some kind of atmospheric effect happening.
Unless there is, okay, you're gonna have to come up with that. That was an extraordinary claim.
Well, there's optical effects happening even in your model. There's just optical effects happening even in your model.
Yeah, we quantified them, and it's not nearly enough to make the sun stay the same size, or nearly the same size, or a fraction of an arc second from noon to sunset over the course of a day. With the sun being 4,000 miles, with the sun 4,000 miles away, ain't happening.
Well, I don't know about 4,000, but there could be a
magnification effect happening. Yeah, pick a number because the number is 93 million, and when you do the math with 93 million.
Are you good? Are you freaking out, Larry?
Yeah, that's why I usually point to the moon instead. Like the full moon doesn't change size more than 1 or 2% throughout the night. And we know it's not due to atmospheric effects because we can see the shape of the constellations behind the moon are not being affected.
Yeah, you don't know that it's due to atmospheric effects.
We know that
behind it. You don't know that it's not. The stars behind it maybe not being subject to those effects, and the moon is. So you don't know jack shit because you're not doing geometry on the sky. That's the problem. You don't have any actual geometry
throughout the night. And we know it's not due to atmospheric effects because we can see the shape of the constellations behind the moon are not being affected.
Yeah, you don't know that it's due to atmospheric effects.
We know that it's
behind it. You don't know that it's not. The stars behind it maybe not being subject to those effects, and the moon is. So you don't know jack shit because you're not doing geometry on the sky. That's the problem. You don't have any actual geometry because you also always have this refraction thing happening. So you have zero geometry with what you're doing, with what Larry does, Jesse Gordon, Kozlowski, main surveyor. You don't do any geometry. There's always refraction. If you don't account for refraction, you debunk your globe radius. Now I know a lot of you would like to debunk the globe radius, even if it would mean debunking us, just to win an argument with some guy on Discord.
Yeah, I just don't find it plausible that there could be some kind of atmospheric effects that would change the size of the moon to keep it the same size, yet would have zero effect on the stars.
And Earth and Aether are perfectly where I think the conversation should eventually go, and it should be about, because to me that's is debate about with this. As many different topics as there is to debate about with this flat globe topic. I think, the argument to be made for the physics is, that's really the globe killer, and where I think the conversation should eventually go, and it should be about, because to me, that's the point of me arguing flat globe isn't to be like try and dunk on globers in the end, or like prove to somebody that it's flat, because if you know that, it's going to change your life. Like once I figured out that like flat Earth, stationary Earth, and Aether are perfectly compatible, and that that's the alternative explanation to the relativity garbage that we've been fed. That to me is the main point, because it's a real understanding of science that's going to make a change in culture like we want to see.
But don't diss
Go ahead,
relativity,
Jerry.
bro.
And dunk on globers in the end, or like prove to somebody that it's flat, because if you know that, it's going to change your life. Like once I figured out that like flat Earth, stationary Earth, and Aether are perfectly compatible, and that that's the alternative explanation to the relativity garbage that we've been fed. That to me is the main point, because it's Earth and dunk on globers in the end, or like prove to somebody that it's flat, because if you know that, it's going to change your life. Like once I figured out that like flat Earth, stationary Earth, and Aether are perfectly compatible, and that that's the alternative explanation to the relativity garbage that we've been fed. That to me is the main point, because it's a real understanding of science that's going to make a change in culture like we want to see.
But don't diss
Go ahead,
relativity,
Jerry.
bro. Don't diss relativity, bro. Have you heard of the Andromeda paradox?
Dude, that's funny. After you talked about that, it came up on my YouTube feed for some weird, strange reason.
See, none of these are globe killers. Just being contentious against the globe isn't a globe killer. The only globe killer is a model that supersedes it, that does things better than it. That's the only way it's a killer. There's always contention. Contention does not equal killing. Stirring up conversations and bringing up contention and throwing doubt is not killing it. Causing the experts to go, that's not killing the globe. The globe is killed when a better system and a better model is put before it and says, look, everything you can do, I can do too, and better. And on top of that, better. And on top of that, all these things that we make fun of you guys for, we've got a better, refined, more ordered, more proportional system. That's the only way it's going to get killed. Don't fool yourselves, you guys.
And what you want is a replacement. We need to replace your model.
Yeah, falsification is independent of replacement. Also, geometry is what kills the globe. That's why they call the stellanillion eclipse the impossible eclipse. Like, we didn't name it that. That's what that's the mainstream nickname, the impossible eclipse, because it's geometrically impossible.
The globe is flourishing. There's more and more flights
It's actually
as the days goes on. Those flights use the globe model. Shipping routes. Point A to point B.
That's
Oh, we got a little audio chaos.
Satellites in the air now.
We got a little audio chaos going on. Hold on, guys. Hold on a
Flourishing.
second. Gatebreaker, hold on. Guys, there's audio chaos. Let this guy finish his little speech, and then you can go next.
Speech. That looks more like a preach.
Whatever it is, just finish it up. Gatebreaker, let's go.
Yes, the globe is flourishing more than ever before. The model is being used more than ever before. Nothing about the globe is being destroyed.
Okay, good talk.
Which verse is that?
Yeah, that was that.
I enjoyed that.
Yeah, it was good. Hey,
Jerry,
Jerry, have you noticed
That's what
similarity?
I was
Have you noticed similarity between the Grand Canyon and copper mines?
No, what's the similarity? You think it was a giant copper mine?
That looks like, if it was to be back in the day, I mean, I would definitely say that looks like a definitely copper mine.
There's no you don't see it though. Show me, get some pics. Let's get some pics going. Show me what you're looking at here.
All right, this is a copper mine. Sorry, this is a Grand Canyon. And
Yo, that looks dope as fuck. I've never seen it from above like that. That's sick.
Let me give you a good picture of a copper mine. One with water. Let me one with water so you kind of see.
So Gatebreaker, 8 years ago when I discovered the Earth was flat, there was just me at work. Now there's 6 of us. So I don't know. I know more and more people that are figuring it out.
You want to try to hear another speech? Hold on, we're in the middle of this copper mine thing.
For real.
Isn't there like a maybe this isn't it? Isn't there like a nice like carving inside the Grand Canyon somewhere or something? Like an entranceway to a house or something, or maybe that's another place.
That's a copper mine.
All right, big difference though. Here's the differences in spotting right off the rip.
Look at the copper mine.
The spots in the copper mine, those are all level now. That could have been that maybe they're not level now from erosion or something from the Grand Canyon.
Right. That's what I'm saying. Because if you give it time and rain, it'll erode.
You get a little erosion and then it'll slant off like that, the terracing.
Yep. But imagine back in the days, there. Let's say if it was, a few centuries back, before back in the BCs, it wouldn't be as nice as these because usually this is usually done with machinery.
Yeah, they're just doing it, maybe doing it by hand or something, shovels.
Mhm.
Is there a lot of copper in that area?
Not sure.
There's
You
probably
can't touch it?
something. There's probably something there, dude. I mean, if you just go anywhere and dig, you probably find like something in the dirt. You know what I mean? If you
Well,
dig enough
actually,
dirt
in
out.
Utah, you got Catoctin, Kennecott, where my grandfather worked. So that's not too far from the Grand Canyon. That's one of the best copper mines out there. They pulled a shit ton of gold and silver, but mostly copper.
Like you could go get Home Depot sand right now, and you probably find if you go through enough bags, you'll probably find a little teeny bit of gold.
Yeah, I know there's minerals all over the place. Like being in Montana, like I know a little bit about like gold claims and stuff, but I don't know
Like I
anything
don't know
about
why
that
Home
area
Depot's
really.
not. I don't know why Lowe's and Home Depot ain't sifting through that sand before they send it out, dude. They probably get a lot of fucking gold out of that.
I mean, if you think about it,
Dude,
where these all these people get all the metals, the metals and the copper to build their the things that they built back in
you
the
do
days.
know why. I'm sorry. You do know why they don't do that. It's like one little speck, per freaking 1,000 yards would be worth it. But if you had free labor and endless time to do it, yeah, you could get some gold.
Does anyone here buy buy gold to eat?
No, but I know what you're talking about, kind of.
Monoatomic gold?
No, they have that leaf gold that you can use.
Some dude just came up with a new kind too. It's something called biophotonic gold.
I bet he makes a lot of money convincing people that would be a good thing to eat.
Shit, it's
I
better
don't know.
than drinking Goldschlager for you.
That gold's good for you. Just,
You see what I'm saying though, Jeremy? Like where would all these people get all the where were their mines for copper, for brass, for the
It's like
metal?
the odds are maybe 25% that the Grand Canyon's a copper mine. I don't know. Sure looks like one, but then you got a river, but
I mean, you
it's
have
all
water.
like
You have water in the other ones too. Like
can
one
a
that
river carve that out over thousands of years?
No, they're saying millions, bro.
Maybe. I don't know. Big floods, big rivers. I don't know. They sure do look similar though. You could easily see the similarity. It was like a wishbone old style slingshot. It's really cool.
it's interesting. Up the interstate from me a little ways is Butte, Montana, which is like, if I'm not mistaken, it was like the richest hill in the world as far as mining. Like I think they pulled more copper out of there than like anywhere else. And it like she just basically built America with the copper out of that mine. You can go look it up. There's a whole bunch of history behind Butte, Montana. But anyway, I was thinking about like the Grand Canyon, how like Butte, Montana has like a really nasty open pit mine that's like really toxic. And like the Grand Canyon would have like been a way to just keep flushing away all that toxicity. Instead of just having an open pit mine, it was like an open river valley.
Yeah, they used to use something. Yeah, what chemical though to get the copper? Like there's McKinley. I think it's McKinley. Somewhere in Alaska. There's an old mine up there that Kennecott also owned. That was the same company that used to own the one in Utah. One of the biggest mines in Alaska.
Yeah, McCarthy. I remember that.
Yeah, McCarthy, not McKinley. Yeah, you're right. Yeah, there's a show on it about the in fact, Lake Louisiana has a family still living there on there. They don't watch.